here we have a molecule of ethene. You can see it's ethene because it's got the double bond. And this is a monomer that we're going to polymerize. So when polymerization occurs, one of the double bonds breaks, and that allows molecules to add on to make the chain bigger. So if I've got another molecule of ethene here, what happens is it can trigger a chain reaction where I get the molecules starting to make a longer chain. And this can just keep going. So I've got another one, bumps in here, opens that one out, it can add on. Alright, again, it can keep going. It's bumping into another ethene. It will open one of the bonds will break, the double bond, and you get the chain lengthening. Last one, another one. So the ethene, one of the double bonds breaks, and it will add on. So this is an example of addition polymerization. So each time we added on a monomer to make the polymer chain longer. So we're still looking at our polyethene molecule. Now it's polyethene because it came from ethene monomers. Okay, so polyethene. So where are our repeating units? So you can see I've got two hydrogens attached to a carbon, attached to another carbon with two hydrogens. And that pattern repeats all the way through the chain. In this example, my monomer is chloroethene. So when chloroethene monomers polymerize, again, one of the double bonds will break in the initiation process, and during propagation we get the chain lengthening. So as that free radical bumps into the next one along, we get the chain lengthening. Okay, and another couple of monomers. Oops. Going on there. And then we have the last one adding on. Now these are very, very short chain polymers. Really, they run to tens of thousands and hundreds of thousands of monomer units. So when we have a chain, we need to have a look and see where our repeating units are. Now, in this case, you can see there's two hydrogens attached to carbon with a hydrogen and a chlorine atom. Then we've got another carbon with two hydrogens, and then another carbon with a hydrogen and a chlorine. So clearly this section, or this section, is our repeating chain. We can just double check that. Yep, those two, and those two. Right, so that's our repeating unit. Now, one of the things you can do with the repeating units when you're given a question like this is where you've got the polymer chain, try and draw the chain so that you've got the where the double bond would be horizontal and everything else up and down so that it's easy to see what's going on. Here's a section of another polymer chain. It looks very confusing at the moment, but let's have a look and see where the repeating units are. So here we have a hydrogen, two hydrogens on a carbon attached to a carbon that has a methyl group. Then we have a carbon attached to two hydrogens attached to a carbon with a methyl group. Okay, I can see the pattern now. So I've got two hydrogens, then a carbon with a hydrogen and a methyl group. So the way I could organise that to make it all look flat for the moment, so I can draw my monomer, is having the monomer with one carbon, hydrogen up and down, attached to a carbon, the black one, with the hydrogen going up and the methyl group going down. So I can see from that my actual monomer for this one would in fact be, if I rebuilt it, would in fact be this molecule. Once I join that double bond back in. So what's that molecule? Let's have a look and see if we can name it. So it's got three carbons, so it's going to be a prop. It's got one double bond, so it's going to be an ene. So there's no other substituents or anything, so that is propene. So my long chain polymer, here's the other section of it that I haven't pulled apart, has got, goes around that way, has got one methyl group going up or down, depends which way you draw it, okay, with a hydrogen, okay. So what that means is that this whole thing is my repeating unit, but the only thing that opens out is the double bond between the two carbons. All right, remember, one of those bonds in the double bond breaks and opens out so that it can join on, which is why we get that methyl group going up and down, up and down along the chain. So this one's called polypropene.